Turn children's scribbles into Pixar-quality animations. Magic demo. Imagine the scene. A piece of construction paper, crinkled and smudged with the earnest effort of a small hand. Upon it, a creature of pure imagination. A dog with 6 legs, perhaps, or a smiling, lopsided sun with rainbow rays. For generations, these masterpieces lived on refrigerators, fleeting testaments to childhood creativity. But what if you could take that drawing, that unique scribble, and breathe life into it? What if you could watch it run, jump, and emote in a fully realized, three-dimensional world, with a lush lighting and soulful character of a Pixar film? This is no longer a flight of fancy. It is the new frontier of creative artificial intelligence, a magic trick where the wand is a sophisticated blend of generative models and 3D artistry. The magic demo that makes this possible is not a single button, but a fascinating pipeline, a relay race of specialized AI tools working in concert. The journey from static scribble to animated star is a multi-stage process, each step dissolving a layer of the impossible. Stage 1. The digital seance, interpreting the scribble. The first and most crucial challenge is for the AI to understand the intent of a drawing that often defies anatomical and physical laws. This is where the AI acts as a creative partner, not just a tool. The primary weapon here is a class of models known as diffusion models, the same technology that powers tools like Midjourney and Stable Diffusion. However, we don't just feed the drawing to a standard image generator. The process begins with a conditioning step. Using a tool like Stable Diffusion with ControlNet, we can impose strict guidance on the AI's interpretation. ControlNet allows us to use the child's drawing as a control map, like a puppet master string. We input the scribble and specify a conditioning type, such as scribble or canny edge. The AI is then tasked with generating a photorealistic or stylized image that faithfully adheres to the outline and composition of the original drawing. The magic phrase, or prompt, becomes a collaborative dialogue. A parent might type, "A cute, fluffy, three-eyed dog, Pixar-style, 3D render, soft lighting, playful." The AI, constrained by the ControlNet outline of the 6-legged creature, then generates a professional-grade 2D image that looks like a still from an animated movie, yet is unmistakably the child's creation. It has interpreted the squiggle as fur, the misplaced eye as a charming feature, and the lopsided smile as a character trait. Stage 2. From flat to fat, the 3D miracle. A beautiful 2D image is only half the battle. Animation requires a three-dimensional model that can be posed and lit from any angle. This is where the process becomes truly alchemical. Historically, this was a task for a skilled 3D modeler, taking hours or days. Now, AI tools can achieve this in minutes. The leading technology for this is generative 3D modeling. Tools like TripoSR, CSM, generative structured motion, where the underlying technology of NVIDIA's Get 3D are pivotal. These models are trained on millions of pairs of 2D images and their corresponding 3D models. They work by predicting the depth, geometry, and texture of an object from a single 2D view. In our pipeline, we feed the AI-generated Pixar-style image from stage 1 into one of these 3D reconstruction models. The AI analyzes the image, makes intelligent assumptions about the parts of the creature it cannot see. Is the back furry? Is the tail straight or curly? And outputs a fully textured 3D mesh. This file, often in .obj or .fbx format, is now a tangible asset. You can import it into any standard 3D software like Blender or Autodesk Maya and rotate it, zoom in on it, and see it from every angle. The two-dimensional sun now has a round, three-dimensional body. The 6-legged dog has volume and form. Stage 3. The spark of life, rigging, and animation. A 3D model is a digital statue. To make it move, it needs a skeleton, a process called rigging. Manually placing bones and joints is complex, but AI is once again streamlining the process. Research models from places like Google DeepMind are exploring automated rigging, where the AI analyzes the 3D model shape and proposes a plausible skeletal structure. For our demo, we might use an auto-rigging tool like Mixamo or a similar plugin for Blender. With a rig in place, animation begins. This is the final piece of the magic. We can no longer rely on static prompts. We need to describe motion. This is the domain of text-to-animation AI. While still emerging, powerful tools exist. We could use AI-powered animation suites within Blender or game engines like Unity or Unreal Engine with their integrated AI plugins. The process becomes a director's session. In a tool like Cascadeur, an AI-assisted animation software, we could use the auto-physics feature to make our six-legged dog jump realistically. Or we could use a text prompt, animate the character to wag its tail happily and do a little clumsy spin. The AI would then generate a sequence of poses, applying the principles of animation like squash and stretch, anticipation, and follow-through, all tailored to our unique model's proportions. The complete workflow, a symphony of AI. So, to recreate the magic demo yourself, the exact workflow would be 1. Digitize. Scan or take a clear photo of the child's drawing. 2. Interpret. Stable Diffusion plus ControlNet. Use a platform like Comfy UI or Automatic 1111 to run Stable Diffusion, using the drawing as a ControlNet input and a descriptive Pixar-style prompt. 3. Model, TripoSR or similar upload the resulting AI-generated image to a web-based 3D generator like TripoSR to create a 3D model. Download the mesh and texture files. 4. Animate. Blender plus AI plugins import the 3D model into Blender. Use an auto rigger to add a skeleton, and then leverage AI animation tools or pre-made motion capture data to bring your character to life. Finally, render the scene with a high-quality, cinematic lighting that defines the Pixar look. This is not science fiction. It is a workflow being pioneered by artists and developers today. The true magic, however, lies not in the algorithms, but in the human connection it forges. It validates a child's creativity in the most profound way possible, telling them, your imagination is so powerful, the world can see it move. It transforms a parent from a passive admirer into a creative collaborator in a grand, technological story. We are witnessing the dawn of an era where the barrier between imagination and manifestation is not just lowered, but delightfully dissolved. If you found this video informative, please like and subscribe. It will really help this channel out. Thank you for watching. Stay tuned for more informative videos coming.